Have you ever found yourself tangled in the complexities of C++ templates? It can be quite a puzzle, right? If you're struggling to obtain the original struct or class name during template instantiation, you're in the right place. Today, we're diving deep into this intriguing topic. I totally get it. The world of C++ templates can feel overwhelming, especially when you're trying to figure out how to assert conditions at compile time. You're not alone in this. Many developers face similar challenges. Here's the specific question we're addressing today. One user asked, is it possible to obtain the original struct or class name during C++ template instantiation? They provided a code snippet where they wanted one assertion to return true and another to return false. Sound familiar? Let's explore this together. So what exactly is happening here? The user wants to know if a certain template condition can be true or false based on the types being compared. This involves some advanced C++ template metaprogramming concepts, which can be tricky but fascinating. And stick around. By the end of this video, you'll not only understand the solution, but also gain insights into template metaprogramming that can elevate your C++ skills. To achieve the desired behavior, the user can create a type trait that compares the original types of the template parameters. This will help determine if the types are the same or different. Next, the user should define a specialization of the type trait that will be used to compare the original types of the structs. This specialization will help in the static assertions. Now, the user can implement the comparison logic using the previously defined type trait. This will allow the user to check if the original types are the same or different. Finally, the user can use the comparison in the static assertions to validate the conditions specified in the question. This will ensure that the assertions behave as expected. Fun fact, did you know that C++ was originally designed to enhance the C programming language with object-oriented features? Now it has evolved into a powerful tool for template metaprogramming. Now let's look at the answers provided by other users. An alternative solution provided by a user involves using two specializations with template parameters to achieve the desired matching. They define a primary template for XXX and two specializations, one that returns false for different types and another that returns true for the same types. Additionally, the user notes that for a proper type trait, you should derive from std integral constant, using std true type or step false type instead of manually setting the value. That's all for that response. Let's see what someone else had to say. An alternative solution provided by a user involves creating a structure called sameBaseTemplate. This structure uses type traits to determine if two template classes are the same base template. It defines a primary template that defaults to false and a specialization that returns true when the templates match. Additionally, the user suggests a third specialization for cases with non-type template arguments, like std ratio. This allows the same base template to handle more complex scenarios. Here's a pro tip. Always familiarize yourself with the standard type traits in C++. They can save you a lot of time and headaches when working with templates. And there you have it. You should now have a clearer understanding of how to obtain the original struct or class name during C++ template instantiation. Remember, mastering templates can greatly enhance your C++ programming skills. If you found this video helpful, don't forget to subscribe for more insights.